All right, ladies and gentlemen, it's Mr. Arnold here. I'm going to talk a little bit about Unit 2, taking a look at Chapter 16, Section 1, just a real quick review of what's going on here. This is all about the atomic history and understanding how we've gone from not knowing anything about atoms all the way to where we are present day, knowing about the electron cloud and the nucleus, protons, neutrons, electrons, and everything like that. So if we take a look at what we should know by now is atoms are the smallest part of matter, which we've talked about. And they're the smallest part of matter that actually retains all of their physical and chemical properties. So once we get to an atom level, we can't get any smaller than that. And actually, atom comes from the ancient word atomos. And atomos was actually discovered by Democritus, believe it or not. Democritus was an ancient philosopher, and he proposed the idea that if we took an item such as a rock and we cut it down, it would be half a rock. And then if we kept cutting that down and cutting that down, we could continue to cut it until at some point in time we would get to a spot where we would not be able to cut it anymore. And he coined that term atomos, which actually represented undivided or indivisible part. So that's where atomos comes from. Believe it or not, it was an ancient word. Democritus was the first one to propose the idea, but he had no evidence to kind of confirm that, so therefore he was never given credit for that. It wasn't until about 2,000 years later where atomos finally turned into atom, and that's because Mr. John Dalton was able to start providing evidence for us to actually see what that is. And John Dalton is given credit for being the father of atoms. So, knowing that, what we know is inside of an atom we have multiple parts. And inside those atoms, those multiple parts tell us what's actually going on. We've got some parts that are positive, which is fine. We've got some parts that have no charge, and then we have some smaller parts that kind of are floating around this outside area, which are negative charges as well. So if we take a look at our atom and we're kind of looking to see what goes on, we need to be able to identify or at least label those parts. So these parts that are coming from all the way out here are electrons, which you should know. Those electrons are actually found in the area outside of this central part. This central part we call the nucleus. And the outside of that is the electrons. Those electrons are found in what we call the electron cloud. So inside of the nucleus, these positive parts, they have a positive charge, are our protons, which you guys are all probably familiar with. And then the parts that don't have a charge or are neutral, we call neutrons, again, which you all should be familiar with. So just kind of recap real quick. We have atoms, which are the smallest part of matter that retain the value. Atoms actually come from the term atomos, which was actually discovered by ancient philosopher Democritus. Because he didn't have evidence for it, he was never given credit. It wasn't until John Dalton came later on, and he had the evidence that actually proved the existence of atoms. An atom has a nucleus, which is the central part. Inside of the nucleus, we have protons and neutrons. Protons have a positive charge. Neutrons have no charge. And then outside of the nucleus, we have our electron cloud, which is this kind of area that surrounds the actual atom itself. And those electrons have the negative charge found outside the nucleus. Electrons are what we're going to be using when we start talking about the bonding of atoms. So as we kind of keep moving on, some things that you need to be somewhat familiar with the atoms and the structure of the atoms. Just a couple of things and kind of how we figured out what was going on with these atoms. As scientists started to learn about the atomic theory, they started doing experiments. One of the experiments you are going to be responsible for is Rutherford and his gold foil experiment. Wow, gold foil, sorry, trying to spell too many things at one time there. Gold foil experiment. Essentially, what Rutherford did was set up this screen around this very, very, very tiny piece of gold foil. And then what Rutherford did was took this machine and actually shot these positive parts at the gold foil. What Rutherford expected to happen was these positive parts should hit the gold foil and bounce off because the gold foil is solid. What he actually found out is the majority of those positive parts actually went through the gold foil and hit his little screen in the background and counted the number that actually came out. And thousands of those passed through. He also had some small sensors off to the side, and what he found out is occasionally some of these parts bounced off and hit to the sensors that were out on the side. So what he was able to conclude from this was a couple of things. That number one, if the parts were able to pass through the gold foil, that gold foil itself should be mostly empty space. And again, because most of them pass through, there's a lot of space that's in between there. Number two, there had to be some sort of dense, positive part that the particles were bouncing off of. And again, since these were positive particles being shot out by the machine, if we take a positive and a positive and we put them close by each other, we know that they are going to repel. So then these positive parts that are getting shot out to the side and bouncing off to the side must be hitting a positive part of the gold foil, which he then said was the nucleus. Sorry about that. Let's start all over there. Nucleus. There we go. So, Rutherford's gold foil experiment found a couple of things. Found number one, that most particles actually shot through. Since most particles actually shot through, we must be mostly empty space, meaning the atoms themselves. And then we also found that some of the particles bounced off. Since those particles bounced off, they must be being repelled, so that there must be this dense positive part in the middle, which he called the nucleus. And again, this dense positive part was the nucleus there in the middle. Again, just some of the experiment, or one of the experiments that helped us understand what was actually going on with that, with the atom itself. Now, knowing this information, we actually had Niels Bohr come, who was a German scientist. What Bohr was actually able to do was to take Rutherford's atom, which he had this circle with positive parts inside of there. And remember, if most of the positive parts were on the inside, then the negative parts had to be scattered around on the outside. And what Bohr concluded was that there were these levels. That we had this dense positive part in the middle, and then you had a level, and then another level, and then another level from there. And each one of those levels housed electrons. And those electrons were the negative parts that were actually moving around the positive nucleus of the atom. So Rutherford helped us discover the positive nucleus. From there, Bohr took the positive nucleus, started to put the levels. These levels will become important when we start talking about bonding, because we need to know how many are on each level. Again, just a little bit about atoms, some of the things that you should know or you shouldn't be familiar with in terms of atoms and the parts and stuff like that. One of the things that I forgot to mention is that the parts of the atoms, the protons and neutrons, are actually not the smallest parts that we know of all matter. There are smaller parts that are actually called quarks that make up, and that's an R, sorry, quarks that actually make up the protons and neutrons. So they're not the smallest part. The quarks are actually smallest, but they cannot stand alone. So atoms are the smallest part of matter that retain all the properties. Atoms are made up of a nucleus and an electron cloud. The electrons are found in the electron cloud, and they have the negative charges. The positive nucleus is in the middle, and those are made up of protons and neutrons. And protons and neutrons are made up of quarks, which are the actual smallest part of all atoms from there. Other than that, that's pretty much where we're at. The good thing is these electrons move so stinking fast that we really can't draw right where they're at. They're going to be constantly in motion. All we can do is kind of predict, but we will never know exactly where those electrons are.